Hi, now in this tutorial we will continue solving the exercises for our Oracle practice. Now we will solve exercise number 3. So exercise number 3 we're supposed to solve 5 queries. And for those 5 queries you should have created these tables already. So and we did that actually in exercise number 1 and then you populated the tables. So and these are the same queries that we did with algebra. So I just need to illustrate this. So in algebra, we were saying that this was a pi on students on age. So I want to illustrate what will be the something that will be equivalent in this case. So I will do select, and then the way that we do the pi, which is the projection, I want to project over age. So select age from students. So in this case, the name of the table is actually student, and then we end the statement with a semicolon, and this is the answer. So then you just need to execute that. My table is still empty because I didn't implement it, but I could go and test it. We'll test it anyway. So I will test that in two different ways. So I'm gonna copy this. We'll go here, paste it. And then in your case, it shouldn't say no row selected because you populated yours. Now, this is the answer for the first query. Let's do something else that I like to do, what we call an alias. I'm gonna call my table student S, and then we use that S dot. So we will use this format when solving queries. So again, I will copy this. This is the way that I want you to actually implement it. Paste it. So I think that's a nice practice. I mean, even though we didn't have to name the table student as S, I'm using that. Okay, so now for the next, so let's highlight the answer over here. Now, question 2, this is the name of all the students. This will be a select name from student. And then again, if I do the S, this will be then, well, actually here is S name, so it should be S dot S name, right? Then we will copy this and implement it right here. Now you can also do that in a script you like. So then this will be my second query. Now for the next query is the one that we will combine the pi and the sigma, right? So we want the name, so we want select S name, comma S dot age from student S, where that will be my sigma, where S dot age greater than 30 semicolon. So again, you can compare this with what we did with algebra. So we'll copy this. I hope I don't have any typos. Paste it. And again, I don't have any answers, but I'm implemented that they are okay. Okay, my fourth query is the one in which, oops, in which we want to do a Cartesian product in its student title of each course that the student currently takes. So in this case, it's not the same name of the tables and the same schema that we have in the algebra, but I just want to illustrate that up to the join. And I will do the other, we will have next week more about SQL, but I just want to have you some practice now. So here we want to select the SID, in this case is SNUM in this table, so it's SNUM and title. So title, in this case, the name of the class. So class, I'm gonna call that C dot name. That will be the title for each course that the student currently takes. So from, I will need now two tables. I will need, well, I actually will need three tables, right? I will need a student, which is going to be S, comma, we will also need enroll, we will call that E, and we will need class C. By doing this, by listing these three tables, this is the equivalent of doing the Cartesian product. And this is the pi over the Cartesian product, and now we need to do the sigmas, which is going to be my where, and then I will need to do in that Cartesian what will be my join. So we're going to join the students, which is s dot snum equals to, we join that with enroll, e dot snum. So they need to match, and we will need to join enroll with class. So enroll will be e dot cname equals to c dot name, and that's it, right? We don't need anything else. And we'll end the statement with a semicolon. So I will select this and see if I have any errors. So then I paste it. Seems that it's okay. So on yours you should see some answers. Okay, then and then you can verify that the answers are okay. So finally, the name of the students who are history majors taking CSCI courses of at least 3 credits. So now in here we don't really know if a class is offered by a department, but we know who teaches the class, so there is a faculty ID. So we're going to assume that if somebody from the CSCI department teaches the class, then the class is a computer science class. So we're making that assumption just to solve this. So we do a select. So we need the names of the students, right? So it will be S, that will be my table student, and that will be S name from, and we need to decide how many tables we need. So we need a student for sure, and then who are history major, so that will be a sigma on the students currently taking, so we will need enroll again. That will be my E, so we're gonna have to join, and then the taking a class, and we will need faculty in this case. Let's call that F. Then where, let's put now the sigmas, where well, we need to join S dot snum with E dot snum again, and we need to join enroll with class and E dot C class, no, C name, I'm sorry, C name equals C dot name, and we need to also join within class and faculty, right? So then class has a faculty ID and faculty has a faculty ID. So we need an C dot FID is the same as F dot FID. So I think we're done with the joins. Now let's see the conditions. So history majors. So now where, so on the table we got major, so we got S dot major. Now you need to check on the data and the table how is that they call that. Well, let me see, I think I had that open over here. English history right here, so I got the spelling now. Okay, so then is history. So check that. So we got the history majors currently taking CSCI courses of at least 3 credits. And let's see if we can get the credits. You know what? We don't have the credits here for classes, so we will ignore that because we don't have it. I mean, I copied that from the previous thing, so ignore the one for credits because we don't have that information. and then now we will say that the faculty F dot um, dep ID equals now faculty, and for the faculty we have a number for the computer science, so we don't really know. So let's assume that the computer science is 20 because that's what we have there. So here, let's go back. The point is that I want you to implement the tables that I had from my relational algebra were fictitious. Control C, then paste it. Okay, I see that I have a typo on S major, so let's go back over here. So here I put a comma over here, so this is a dot. Okay, so I will connect this again. And again, this we couldn't match this from the we were doing in algebra because we don't have all that information. I need to connect again. So I will pause what I'm connecting. Okay, I have a typo. I put where twice. So let's take that word away. It should be N. Then depth, we need